let's take a look at some pairs of lines and see if we can determine if they're parallel, perpendicular, or neither. Recall that as a result of the parallel lines theorem, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. That's the parallel lines theorem. So anytime the slopes are equal or the same, then the lines are parallel. The perpendicular line theorem says that in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is equal, is a -1. Sorry about that. Vertical and horizontal lines are perpendicular. Well, keeping this in mind, let's look at some lines to see whether or not they're parallel, perpendicular, or neither. Well, I have line AB and line CD. Are they parallel? Are they perpendicular? Or neither? Recall, if we can compare the slopes, remember the slope formula. Rise over run, compare the slopes to determine if these two lines are parallel, perpendicular, or neither. Let's use rise over run. For line AB, the slope for line AB, I'm going to start at point B. I'm going to rise and then run. So the slope for line AB, 1, 2, 3, 4, 5, 6. The slope, line AB is equal to 6. This is your rise over run. 1, 2, 3, 4. But notice it's -4. When you simplify, that's equal to a -3/2. Okay? So let's look at the slope of line CD. I'm going to rise, start at point D, 1, 2, 3, 4, 5, 6 again. And then I'm going to run 1, 2, 3, 4, but it's negative. When I simplify that, that's a -3/2. Look at that. The slopes are the same. Therefore, we can say that line AB is parallel to line CD. Okay, let's try another one. Okay. We have two lines, UV and line TS. Let's write this formula over here. Line TS, the coordinates for point T, let me go ahead and write those down. 0, 4, and point S, 2, 0. Okay? Now, the slope for line TS is equal to, it says y2 minus y1. Let's start here. 0 minus 4, which is, and then, let's go ahead and do the x's. 2 minus 0 is equal to -4 over 2. And what's that equal to? -2. So the slope of this line is a -2. Let's do the slope of the other line, UV. Alrighty. I'm going to just go ahead and do these. V The coordinate for point V, I better write those down because I tend to forget sometimes. Let's go ahead and do U, which is 0, 0, and V, which is 5, 2. Okay, now let's substitute in the formula. UV, 2 minus 0 over 5 minus 0. And what do we get? We get 2 over 5. So we've computed the slopes of both lines. But wait a minute. When I look at these two lines, it looks like they're perpendicular. But when I look at the slope of line TS, which is a negative 2, and the slope of line UV, 2/5, they're not equal, nor is their product a negative 1. It looks like they are perpendicular. But once I actually found the slopes, I can now say, although they look perpendicular, they are not perpendicular. So they're neither. That's why it's so important to compute the slope and then compare the slope. Let's try one more. Okay. We have two lines, FG and JH. Let's determine if they're parallel, perpendicular, or neither. Well, it looks like they're intersecting, so I know they're not parallel. But let's go ahead and compute and find out what they are. We have line FG, the slope of line FG. The coordinates are, I'll put them here, negative 2, down 3, and for G, the coordinates are 4, negative 1. Okay. Let's do this. X1, Y1, X2, Y2. Okay. Now, the slope of FG is equal to, let's go negative 1 minus negative 3 over 4 minus a negative 2. Remember, in subtraction, add the opposite. So what do we get? Here we have 2 over 6, and that's equal to 1/3. So that's the slope of line FG, 1/3. Okay? Now let's figure out the slope of JH. And the coordinates for point J, 6, 1, J, H, and looks like it's 5, negative 2. Okay, I'm going to go ahead and call this X1, Y1, X2, Y2. All right, let's subtract. Negative 2 minus 1 over 5 minus 6. Okay, what do we get here? Negative 2, remember subtraction, add the opposite. This becomes negative 3 over negative 1. And that's equal to a positive 3 over 1. So now we have, or just 3. Now we have a positive 3 over 1, or 3, for the slope of JH. We have a positive 1/3 for the slope of FG. Let's compare those slopes. Are they equal? No. So they're not parallel. Is the product of these two a -1? No. As a matter of fact, it's what? 1. It has to be a -1 for them to be perpendicular. So now I can say they're not perpendicular, so they're neither. Again, parallel lines, the slopes are equal. Perpendicular line, the product of the slope is a -1.